Hello everyone, welcome back to TechOps tutorial. In this video, we are going to set up Docker from scratch. We will cover the installation process on two popular Linux platforms, Rocky Linux 9 and Ubuntu 25.10. First, we will install Docker and make sure everything is configured correctly. After that, we will understand the basic Docker service, configure user permission, and run our first container. We will also check if the installation is working properly and cover some common issues you may face during setup. By the end of this video, you will have a working Docker environments ready for your lab or real world usage. So let's get started. Before we start installing Docker, let's understand why Docker is useful. A common problem in software environment is the famous phrase, "It works on my machine." This happens when an application works properly on one system but fails on another because the setup is different. Without Docker, we usually need to install dependencies, configure settings, and maintain the same environments on every server. This can take a time and create a problem when moving an application from development to a testing or production. Docker solves this by packaging the application along with everything it needs into one container. The same container can run on your laptop, a test server, or a cloud environment. This gives team a more reliable way to build, test, and deploy application. Before installing Docker, we need to check the basic system requirements. First, the system should be running on 64-bit Linux operating system. Docker also needs enough CPU and memory to run a container smoothly. For this setup, we recommend at least 2 CPU cores and around 4 GB of RAM. We should also have enough disk space because Docker stores the images, containers, and other required files on the system. An active internet connection is required because we need to download Docker packages and container images. Finally, we need sudo or root access to install Docker and make the required system changes. In this tutorial, we will work with Rocky Linux 9 and Ubuntu 25.10. Now that the requirements are clear, let's move to the installation step. Now let's look at the different way to install the Docker. There are three common methods we can use. The first and the recommended method is installing Docker from official Docker repository. This gives us the latest Docker engine package along with regular updates and security fixes. The second option is using the operating system's own package repository. This is simple because we can install Docker using the tools like apt or dnf, but sometimes the available version may not be the newest one. The third option is offline installation. This method is useful when the server does not have a direct internet access. We can download the required packages separately and install them manually. For this tutorial, we will use the official Docker repository because it is the common approach used in most DevOps environments. Before we start running containers, let's understand how Docker works behind the scene. When we type a Docker command like docker run nginx, we are using the Docker CLI. The CLI is the tool where we enter the command. It sends those commands to a Docker daemon. The Docker daemon is the main service running in the background. It manages the image, container, network, and storage. For example, when we run an nginx container, Docker first checks if the nginx image is available. If the image is not present locally, Docker downloads it. Then Docker creates a container from that image and start the application. So the simple flow is user run a command, CLI sends the request, Docker daemon creates the container, and finally the application starts running. This is the basic workflow behind every Docker container. So what exactly is the Docker daemon? The Docker daemon, also called Docker D, is the background service that makes Docker works. Whenever you run a Docker command, the command is sent to a Docker daemon. The daemon then does the actual work behind the scene. For example, when you build an image, the daemon handles the build process. When you start or stop a container, the daemon manages the operations as well. It also takes care of Docker network, volumes, and overall container lifecycle. You can think of a Docker daemon as the main engine of Docker. Without it, Docker command would have nothing to execute. On Linux system, you can check whether the daemon is running by using systemctl status docker command. If the service is active, Docker is ready to create and manage the container. In short, the Docker daemon is the background service responsible for building the image, running the containers, managing the storage, and handling the networking across your Docker environment. Now that we have covered the core Docker concept, it's time for the live demo. We will start with Rocky Linux line and go through the complete Docker installation process step by step. First, we will configure the Docker repository, and then we will install Docker engine and its required components. After that, we will start the Docker service and enable it to start automatically after reboot and verify that everything is working correctly. Next, we will configure Docker group permissions so Docker commands can run without using sudo every time. Finally, we will run the hello world container to confirm the Docker is installed and working as expected. We will then repeat the same process on Ubuntu 25.10 so you can see how the installation step compare across different Linux distributions. And since real world environments don't always go smoothly, we will also cover some common issues you may run into. We will look at the situations like the Docker daemon not running, permission error, Docker commands not being available, and repository or a package related problems. By the end of this demo, you will have a complete understanding of how to install, verify, and troubleshoot Docker on Linux system. Let me access the terminal. Now that we have covered the core Docker concept, let's move to the practical section. For this demo, I am using two virtual machines running on my VirtualBox. The first VM is Rocky Linux 9 and the second VM is Ubuntu 25.10. We will first complete full Docker installation on Rocky Linux, including verification and permission. Then we will repeat the process on Ubuntu and compare the steps between the two distributions. So let's get started. Before installing any software, let's verify the operating system version. You can see the name is Rocky Linux and version is 9.7. Before installing Docker, let's confirm it is not already available on the system. There is no Docker. If Docker is not installed, the command will return no output. This confirms we are starting with a clean system. We will first install the package required to manage repository. Sudo dnf install -y dnf plugins core. Enter the sudo password. It is already installed. We are ready to add Docker official repository. Instead of using older packages from the operating system repository, we will use Docker's official repository. You can use this command. Let's verify that the Docker repository has been added successfully. Run sudo dnf repo list. You can grep to Docker. You should see the Docker repository listed in the output. Now we will install Docker engine along with the required components. This may take few moments depending on your internet connection. I will pause the video. Once this is done, I will resume back. We have installed the Docker engine. We need to start the Docker service and enable it to start automatically after system reboot. You can run sudo systemctl enable now Docker. Let's verify that the service is running. Sudo systemctl. The service is running. Let's confirm Docker is enabled during the system boot. From here also you can see it is enabled. but we have the command. From that also you can check systemctl is enabled docker. It is enabled. Now let's verify that docker has been installed successfully. Run docker -- version. You should see the installed docker version. If you want more details, you can run docker version. Means just you need to remove -- in front of version. You will get more details. Notice that the output contains both client and server session. This confirms that Docker CLI can communicate successfully with the Docker daemon. Let's display additional information about the Docker environment. Docker info. Here you can see you will get a more information, and also you can run like egrep server version, storage driver, what else, docker root dir. Notice some useful fields: server version, storage driver, docker root directory. Docker info command is often used during troubleshooting. Currently, Docker commands require appropriate permission to communicate with Docker daemon. Let's first see what happens when a regular user tries to run Docker commands without a required permission. Docker ps permission denied while trying to connect to a Docker API. As you can see, the command fails because the current user does not have a permission to access Docker daemon. However, if we run the same command using sudo, it works successfully. Sudo docker ps. So this command works. Since sudo runs the command with evaluated permission, Docker can communicate with the daemon successfully, but using sudo for every Docker commands is not convenient. Let's configure Docker so our user can run Docker commands directly. Sudo usermod -e capital G docker add this user $user. I will show you. This command adds the current user to a Docker group. For the group membership to take effect, log out and log in back. Now let's test the Docker again without sudo. It works. If the command runs successfully without any permission error, the configuration is working correctly. Now it's time to run our first Docker container. You can run docker run hello world. So let's see what happened behind the scene. First, Docker checks whether the image exists locally. If it does not exist, Docker download it from the Docker Hub. Then Docker creates a container from that image, start it and display the message and exits. If you see hello from Docker, this message, everything is working correctly. Now you can check Docker images. You should see the hello world image listed and docker ps-a. Notice that the hello world container appears with an exit status because its task completed successfully. Now let's perform the same installation on Ubuntu. I have already taken the SSH access of Ubuntu. The overall process remains the same. The main difference is the package manager and repository configuration. Let's verify the Ubuntu version. TCOS release. You can see the version is Ubuntu 25.10. Verify the Docker is already installed or not. You can run with which Docker. No output indicates Docker is not installed. Update the package information. Now install the required package. It's already installed. Now create a key directory. Now add the Docker GPG key. Now provide the permission chmod read permission etc apt key rings / docker.gpg. Now add the Docker repository, verify the repository, sudo apt update. Here you can see a Docker repository information being downloaded successfully. Now install Docker engine. This will take some time. I will pause the video and resume back. We have installed the Docker engine. Now let's start and enable the Docker. Sudo systemctl enable -- now Docker. Now let's verify the service. Sudo systemctl. Here you can see the service is active and running, and it is also enabled. Verify the version. Same command you can run here as well if you want more information about the Docker. Here you will get the client and the server information, and also you can check Docker info. Now let's run the hello world container. Docker run hello world. Here you can see hello from Docker. If you received hello from Docker message, the installation is successful. Now let's verify the images and container. Docker images. You can see the image, and also you can check docker ps-a. Now let's see some common troubleshooting commands. Assume you cannot connect to a Docker daemon. You can run the command sudo systemctl start docker. This will be the command. And if you get any permission denied error, you just add sudo usermod -ag docker $user. By using groups, you can see the admin user is already added to the Docker. Then log out and log in back. And the next issue is Docker commands not found. In that case, you can check with which Docker. You should see user bin Docker. This command verifies the Docker installation completed successfully. And if you face any issue like repository or package errors, verify the internet connectivity and confirms that the Docker repository has been added correctly. At this point, Docker has been successfully installed on Rocky Linux and Ubuntu. We have verified the installation, configured the permission, run our first container, and learned how to troubleshoot common installation issue. That's the end of our demo. Let's switch back to our slide. That's bring us to the end of this session. Today, we started by understanding the requirement of Docker and the basic Docker architecture. We looked at the key components, including Docker engine, container, images, and Docker daemons. After that, we installed Docker on both Ubuntu 25.10 and Rocky Linux 9. We also configured Docker group permission and verified the installation by running our first container using the Hello World image. Finally, we covered some common issues that you may encounter during installation and how to fix them. In the next episode, we will move on Docker images. We will learn what Docker images are, how they work, where they came from, and how Docker uses image layer. We will also explore Docker Hub, pull images from registry, and learn the most important image management command that you will use regularly. If you found this tutorial helpful, Consider subscribing to the channel, liking the video, and sharing your questions in the comment section. Thanks for watching. I will see you in the next episode where we will dive into our Docker images.